The previous two videos were all about what is the pattern of electrons, protons, attraction, and how does that turn into the most important properties. But when do we use those? Knowing those facts, just to know those facts, isn't important. It turns into how do these things react. So here we're going to look at a reactivity pattern. I put on the left side of this chart metals because metals are found on the left side of the periodic table. I put nonmetals over here on the right because they are found there. Our cutoff between metals and nonmetals is that zigzag diagonal that goes right across here. So metals are the elements which are most likely to lose electrons. They come first in the formula, they have fewer dots, and when we do it as an arrow diagram, we draw our dots and we draw our arrows. Those are the ones with the arrow pointing away. Because we know they lose electrons, we can say that the easier they lose those electrons, the better or the more reactive they become. So, an easy losing of electrons is a very, very reactive metal. And we can go back to the patterns that we said over here. Ionization energy is losing electrons. When we're thinking about metals, we're thinking about losing electrons. So the ones that are easiest to lose electrons are the big ones and the weak ones. The biggest element, the weakest element is right down here in the corner, and it's francium. So that is the most reactive metal, and we'll do some experiments and check out some videos that show those patterns. Nonmetals, on the other hand, they're almost full. The closer they are to full, the more attraction they have to become full, the more reactive they get. So nonmetals are more likely to gain to get to that full energy, outer energy level. And the better it is at gaining, the more reactive it is. So that means for a nonmetal, we're focusing on electronegativity. Things that can gain well react really, really well for a non-metal. We have our pattern right here. We hopefully wrote it on our own periodic table, but all the way over and really close to the top is where that attraction's maxed out. We want the smallest, strongest atom in terms of pulling our electrons. And that's right up here, fluorine. The noble gases get ignored for reactivity because they're already full. So we're focusing on fluorine and francium. F and F are two corners for our most extreme reactivity patterns. So when we come right here, we see that filled in, but we also have right here our summary. The smallest, strongest, most reactive nonmetals are found in the upper right corner, ignoring the noble gases because they won't gain electrons very easily because they have full energy levels. They won't lose electrons very easily because they have strong attraction for those and they're already full. The ones which are most likely to react as far as a metal goes is going to be this corner down here. Largest atom, weakest attraction. Strongest and weakest is referring to the attraction right here. So that's our most reactive metal. So here we've got our patterns: size, ionization energy, and electronegativity. Those patterns are the same ones we wrote here, and they are caused by our patterns in Zeph and shielding. Our metal reactivity, the farther to this corner we get, the more reactive we are. So left to right, if we wanted to do that, left to right, our reactivity goes down. But top to bottom, when we go this way, our reactivity goes up. Once again, the king of metal reactivity is right over here in francium. For fluorine, when we go this way, we're getting better and better and better at gaining. We have more electronegativity, more ability to attract. But when we go down, the nonmetal reactivity decreases. More distance, less attraction, less stickiness there. So it becomes less. That's where these as the corners becomes important. So even though this is slightly different with this video, it'll be really easy to add in those patterns of what happens to our metal and nonmetal reactivity. and we have it on the notes, but that periodic table is what you're going to have in front of you when you're doing your homework, when you're on mastering, when you're on Canvas, when we're working together. Put it all in that one place, and we would then have a resource which we can use. There'll be one more quick video highlighting some things from this, but from here, we're just trying to practice this a bunch.